Right, problem 1, let f be an increasing function with f of 0 equals 3. The derivative of f is given by f prime of x is equal to cosine pi x plus x to the fourth plus 6. And one thing that I struggled with at first is just remembering that this is the function, this is f prime, this is not f. So just keep that in mind as well. All right, part A, it says to find f double prime of x. If I look at this, since I'm at f prime and it's asking me for f double prime, I simply just want to take the derivative. So if I have cosine pi x, we're going to make this cosine of u. So u is going to equal pi x, and so then we know that du is going to equal pi. So if I go to take the second derivative, I'm going to get the derivative of cosine u is negative sine u times du plus 4x cubed, and then the derivative of 6 is 0. So when I go to find this derivative, it's going to be negative sine, put my u back in, put my du in, I'm going to put the pi in front actually, and then plus 4x cubed. So that is my second derivative. All right, part B says, is f concave up or down at x equals 1? Justify your answer. All right, on this one, if I want to know something is concave up or concave down, I need to refer to f double prime, and I just need to find out what's happening at 1. So I'm going to be calculating f double prime of 1. So that is going to be negative pi sine pi times 1 would be pi plus 4 times 1 cubed, right? I know that the sine of pi is equal to 0, so negative pi times 0 is 0, plus 4 times 1 to the third is 4, so my derivative is 4, and since the second derivative is positive, that means f is going to be concave up, and my justifying my answer is going to be because f double prime of 4 is positive. Please notice that I was pretty specific. I didn't just say that f double prime is positive. I said that f double prime at 4 is positive, or I could have said because f double prime is positive at, at x equals 1. So just be careful about that. All right, and one thing I did not say when I started the problem was I specifically picked this problem because I'm guessing on the actual AP test, all of the parts aren't generally related to each other. So you'll notice that in this problem, there's a lot of different things getting thrown at you, and you just tackle each part at one at a time. Right, part C says to find an equation, write an equation of the tangent line to the graph of y equals f of x squared at x equals 0. So we know for writing an equation of a tangent line, we need the slope and we need a point. We know the slope is actually the derivative, so it's going to be f, well actually that's going to be f prime, it's going to be y prime. Okay, so the first thing that we need to do is find y prime. Well, you will notice right here that we're not just going to use f prime because y is equal to f of x squared. So at this point in time, because I have something in parentheses to a second power, I am going to be using the chain rule. So I'm going to let u equal f of x, which also tells me that du, the derivative of f of x, will be f prime of x. So I will be using that information. And before I find y prime, I'm just going to put that y is really, I'm going to be now labeling it as f of u, this whole thing squared. Oh, excuse me. F of the whole thing is u. Sorry. So y is equal to u squared. A little messy, but there we go. Okay, so now when I go to take the derivative, y prime is going to equal the derivative of u squared is 2u du. And now I'm going to plug things back in that I know. So y prime is equal to 2 times u. Remember, my u is f of x, and then my du is f prime of x. All right, I'm looking to get the slope, which is the derivative at x equals 0. So now I'm going to plug in 0. So I'm going to get 2f of 0, f prime of 0. Okay, so let's see if I can do this. When I have 2, f of 0 was given. They told me that it was 3. And then f prime of 0, they did tell me f prime. We have that f prime was given, so I'm going to plug in 0. Pi times 0 will just be 0. Plus 0 to the fourth plus 6. Cosine of 0 is 1. 1 plus 6 is 7. So I know f prime of 0 is 7. So 2 times 3 times 7 is 42, which means y prime of 0 is 42, which means I just found my slope. All right, I also need a point. I know it's going to be 0 comma something. It is not going to be 0, 3 because that is f, it is not y. So now to find to find y of 0, I need to do f of 0 squared. All right, so f of 0 is 3. 3 squared is 9. So my point is 0, 9. So the equation of my tangent line is going to be y minus 9 equals 42 x minus 0. So you could leave your answer like that. If you wanted to rewrite it, it would be y equals 42x plus 9. Okay, part D, again, just a totally unrelated part here. Now they're telling us to let g be the function divided by g of x is equal to f of the square root of 2x squared plus 7. Find g prime of 3. So we want to find the derivative. I'm seeing something in parentheses, which is telling me I would like to use the chain rule, so I'm going to let this be u. So u is equal to the square root of 2x squared plus 7. And I'm going to rewrite that actually as 2x squared plus 7 to the 1/2 power. All right. When I'm taking the derivative of this, I notice I actually ended up with some more parentheses. So it's kind of like a double u within my u. I think I'll call this u1 and I'll call this u2. So u1 is really equal to u2 to the 1/2. Okay. So hopefully that makes sense. And du2 is equal to 4x. All right. So hopefully that did make sense. All right, so to get u1 prime, we'll call it du, I guess, because that's generally where we're heading right here. Okay, I'll put the 1/2 out front, so we get 1/2 u2, and then du2. So this will be to the negative 1/2 power now, because we have to do 1/2 minus 1. So, all right, our du is going to be 1/2 u to the negative 1/2 times du, which was 4x, and I actually replug that back in. Okay, and then I'm just going to clean things up just a teeny little bit here. 1/2 times 4x will be 2x, and then I'm going to move this down to the bottom of the problem and turn it back into a square root. Okay, so that is my du. So now, all that, okay, I have g is equal to f of u. So g prime is equal to the derivative of f of u is f prime of u du. So this will be g prime is equal to f prime. U was the square root of 2x squared plus 7. And then du was 2x over the square root of 2x squared plus 7. Okay, now they asked me to find the derivative at 3. So g prime of 3 will equal f prime square root 2 times 3 squared plus 7 times 2 times 3 over the square root of 2 times 3 squared plus 7. And let's just see if I can figure this out a little bit here. 3 squared is 9, times 2 is 18, plus 7 is 25, the square root of 25 is 5. And then times 2 times 3 is 6. And then we already established that that was 5. All right, so now I need to find f prime of 5. Okay, so when I find f prime of 5, I'm basically just going to go into f prime and plug in 5. So that's going to give me cosine of 5 pi plus x, or 5 to the 4th plus 6, and then it's times 6/5. All right, if you would like to work that out, you go right ahead and do so. Otherwise, I'm just going to leave my answer like that. If you did want to check to see if your answer was right, it was 756 as the final answer, but we could leave it very, very messy. Alrighty, next part. Let h be the inverse of f. So again, notice we're totally switching gears. Find h prime of 3. So we know, because they didn't give me information about h, they only give me information about f. We know, since they're inverses, that h prime of 3 is the same thing as the derivative of the inverse of f at 3. So we're going to go back to that formula that we learned, 1 over f prime of f inverse of 3. Okay, so now from here, please remember that this is going to be 3 comma something, and this is on the inverse. All right, so on the original function, it's going to be something comma 3. And if you'll look at, we have been given the point 0, 3. So if 0, 3 is on the original, then 3, 0 is on the inverse. So the inverse at 3 is 0. So this is now going to be 1 over f prime of 0. And we did find f prime of 0 in part C, and that was equal to 7. So h prime of 3 will equal 1/7. And then we did it.